Okay. Let you see, guys, here. Okay. So yesterday, first simple indexes are we discussed here, and when we created your index on single column, okay, we called as a simple index, and the single column of data how it was arranged in your B tree structure format. Okay, now right, and the same as coming to second one, composite index. So composite index is nothing but when we called as your my index was composite means when we apply indexes or created indexes on multiple column, and of course you know composite primary key is yes or no. So composite means what now? Multiple. Okay, right. So the same as here. Right now, when we created an index object based on multiple columns, then we called as composite index. And what is the syntax of this? The previously single column we taken, now we will take as a multiple columns. Column name 1 and take as column name 2 and so on. Okay, and now see, when we created, okay, your composite indexes on multiple columns, your index on which column wise your index will be prepared. Okay, now, and now we can see the index is preparing based on leading column wise. Which column? Leading column. So leading column is nothing but what now? First column. That means in the order you can pass any number of columns, but it was working on only first column. So which is your leading column is there? Based on leading column only indexes can be prepared, and remaining columns will be using like as a supporting columns, using what now? Supported columns. Okay, now right. So that means you need to take one note point here. In composite primary key, in composite index, in composite index, system will prepare a B tree index, based on leading column wise, leading column wise. Okay, right. So this point should always be keep in your mind. Okay, na? All right. And let you come back and see. And the previously we designed one index here, the column name, and what next? Index name from user underscore ind underscore columns, and where table underscore name is equals to emp. So on this emp table, we created only one index here as of now on the column salary. Okay, right. Now come back here. Now I will created one more index on this table, but this time let you see, I'm creating indexes here with a job and department number wise, for example. So then how I want to prepare this index now? Create table, sorry, create index name I2 on emp of. Okay, na? So here any column you can take. If which column you are taking as a leading column, based on that index will be prepared. So department number and job. Now I'm executing. So index successfully created. And after created, let you come out and see this. And now see, your index is created I2 on department number as well as job. Okay. Then after, but here one thing is observed. Once you created your indexes on multiple columns, yes, of course, it will be supported. But where it was, in which cases your indexes will be activated whenever you want to retrieve your data. Okay, now where it was activated means, for example, if I want to call select a star from under my where class, suppose if I am using leading column, then suppose department number is equals to 20. When this request, when you are sending to your system, then what happened? Your data will be organizing in the form of a tree structure format. So that means here indexes are activated. Which scan is performed here? Index scan. Now, if you want to, for example, suppose if I was retrieving select a star from EMP where job is equals to, for example, salesman, something you given condition, and so many people what they think, okay, sir, job is also one of the column of index. Okay, so what they expected here, they expected this is also performing index scan, but it's not perform index scan. It's perform, which scan is perform here? Default. What is the default? Table scan is performed. Why, sir? Because I said to you, your B-tree indexes are preparing by system based on leading column wise. So here this is in my where class leading column, so index will work. But I am calling non-leading column wise are your retrieval. So when you are retrieving non-leading column wise, definitely indexes are not activated. That means your index page is not preparing here. Okay, na? So index pages are preparing only for leading column wise. So that's why it is not preparing index. If it is not preparing index means what is the by default scan? Table scan. That automatically Oracle server will take a table scan to perform. Okay, na? This is what it was happened. Okay. So now this is, for example, in case if are you calling like this, select a star from EMP, department number is equals to 20 and job is equals to what now? Salesman. If suppose the multiple combination of columns, if I perform here, yes, definitely here again it will be performing what now? Index scan will be performed. So that means finally what you concluded here, when I am creating indexes on multiple column, then leading column must and should be there under where clause. Okay, na? If your leading column must and should be there under where clause. Okay, then only indexes are work. Understand my point now? So now, okay, Let me see. For example, suppose this condition, because single condition already you know. So this condition I will take. But this condition what now? This is just for supporting only. So now your basic, how it was working here, careful observe. Suppose coming back to my table. Okay, this is our table information, right? Now careful observe. So my request is what now? Select a star from EMP where department number is equals to 20 and job is equals to some salesman, something I was given. So now we can see your department number 20. This is the leading column. So that means your root value. What is your root value? 20. Is it visible? Okay. So 20. 20 less than values will save under left pointer. Greater than or equals to save under right pointers. That already say. Same explanation as per data you can go. Now we can see. Now first one you can check. In this is my column. What is the highest column, highest number? 30. 30 compare with the root. Which side? Right side. So now I will go to right side. Right side 30. 30, this is parent level, less than left side, greater than or equals to right side. Next highest value, 20, of course 20. 20 compare with the root, less than, greater than, equal. Equal which side? Right side. Right side already parent is created. Then check with your parent 30, which side? Left side. So left side. Left side will take 20. So now 20, here how many are there? 20, 20 with the clerk is there, one condition. 20 with the clerk is there. Next, 20 with the manager is there. Next, 20 with the analyst is there. 20 with the clerk is there. Next, 20 with the analyst is there. So this is supporting column. As or no? It will be storing. And storing, and what it was there again? ID, row ID. Row ID representing what? Star. Yesterday was given representing star. It was keeping like this. Okay? Then. And remember, next one is what now? 10. 10 will go to where? Left side. So left side will be less than and greater than or equals to. That's it. Greater than or equals to. Okay. Now we can see. What is your condition you return? Select star from EMP where department number is equals to 20 and job is equals to sales. So now it will come to 20. First condition 20. Right side will come 30. Left side will come. So in the left side, these are the 20th information. So in this 20th information, what it will check? 20 plus the supporting column data. Now checking 20 condition false. 20 manager condition false. 20 analyst condition false. 20 clerk false. 20 analyst false. All are false. That means that condition relevant data is available in my table or not? Not. Not means what it will show? No rows. Okay. Now we can see. So now select star from EMP where what? Department number is equals to 20. Job is equals to salesman. Okay. Yes, fine. You will not get any answer. It will searching. But your relevant requested data not there. And one more. End means what? Same row. That already knows. Okay. This is not working. Okay. Suppose my first case. If I am writing. Select a star from EMP. Department number is equals to 20 only. Then what happened again? Same na? Yes. 20. 20 less than, greater than or equals to. Okay. Right side what? 30. 30 less than, greater than or equals to what? 20 only comparing here. So 20, how many rows? First row ID, second row ID, third row ID, 4 and 5. Because 20 how many times is there? 5 times, 5 row IDs. Then when this condition, if you sending to your Oracle server will coming to index page, compare here, coming to right side, coming here, right, coming to left side, first page, where is suppose first page 1, it will go to 1 and pick. Next coming to what? Second page, go to directly second page, pick. Next third, pick. Fourth, pick. 5, pick. That means what happened here, you can so that means first row it will come directly here, picking. Next where it was jump, second, jumping. Next where it is jump, third one. Next where is jump, fourth one. Next where is jump, fifth one. So it means as per index information, your 20th number in which row IDs are available, directly it will go to that row ID and picking. So that is what happened. 1, 2, 3, 4, 5. 5. Out of how much? 14. 14 minus 5. How much? 9. So that means this 9 seconds of time saving. 9 seconds of time saving. Suppose if I'm not created indexes, if I go to table scan, then how many seconds? Go to table scan, how many seconds? 14 seconds you will get answer. But after index, how many seconds I get answer? 5 seconds. That means the difference is how much? 9 seconds. That means once you apply index facility, okay, almost 9 seconds of time will be saved. This is a table scan, this is a index scan. So which is faster? Index always be fast. Okay, no? This is composite index. Right on. Suppose you people are asking doubt. For example, sir, you said okay, but now if I reverse it, this condition, if I'm using first level and this is second level, even though index can perform and department number only taking, job will not take. When job will take? At the time of creation level. Understand? Not retrieving levels. Suppose you say, don't write, concept understand, don't write. So, if say, at the time of creating, suppose you created one more index, careful observe. Okay, in this index, for example, I kept job and department number. So now tell me, now are you created index on which order? Job, comma, department number. Then which is leading column? Job. At this moment, how it is working? This is index scan or table scan? Table scan. This is index scan. This is index scan. Hey, index scan is there now. So now here, this is index scan. Because of reason, job is there. This is index scan. This is index scan. But this is table scan. Because leading column, not there. For example, job. What is the job I said? Salesman. Let you come and see. Salesman. Here if it is character wise, if you want to arrange your data, how the B3 structure format is going on. Okay. What is that? Salesman. So salesman means what is a character? Yes. Yes less than characters will save into left side. Yes greater than or equals to character save into right side. Okay na? Now come back. This is your job. Can you tell me? S, C, M, A, P. 5 characters. Which is biggest? P. P compare with S. Left side, right side? M, N, O, P, Q, R, S, T. So now left side means simple write down. What is that left side? A to M, N, O, P, Q, R, S. That means A to R. P, Q, R. Then after S na. So A to R characters of names keep at left side. Right side S to Z. These are biggest characters. Understand na? So now this is. Let you see. Now what is the P? P comes under which side? In between. Yes or no? That means what? left side. Okay, now left side, what is that? President. Yes or no? President, how many times are there? One time, one star. Keep it. Next, come to yes. Next, what is the P after next? Yes. Actually, what is the biggest? S is the biggest, na? Then A, B, C, D also confusing. S is the biggest. Yes or no? Not P. Yes or no? S is the biggest. Now check. S comparing here what? Equal. Equal means which side? Right side. S to Z. Okay, na? Right side. Now tell me, how many S's are there? 4 times. 1, 2, 3, 4, 5. 4 times or 5 times? 5 times. 4 times. Next biggest, P. P comes under which side? Left side. Now you can give P. Okay, na? P again less than or greater than or equals to. Next biggest, M. M compared to S, left side. Compared to P, left side only, left side. So M will be, how many managers? 1, 2, 3. Okay, na? So like this, your character bases are preparing. Understand, na? Now again, how many stars? 4 stars. 4 stars means what now? 4 row IDs. Then it will go to directly 4 row IDs and taking. Out of 14, 4 minus 4. How much? 10 seconds of time save. Understand, na? So like this, you have to prepare. One concept understand, remaining all are same. Right? Next one. What is the next third one? Unique index. Okay, na? Unique index means what, sir? Here, observe. Suppose are you created your index, okay, na? So when we created an index object based on unique constraint, based on unique constraint. Okay, now tell me. Unique constraint already we discussed. What is the advantage of unique? So duplicates are not allowed. So unique constant, how it will be increasing your performance of database and how to reduce a searching time means, for example, you can say, suppose I have a serial number and here serial number, but in this serial number I was applied a unique. There are two tables now. This is one table, for example, T1, and this is T2. In two tables, I was designed one column. Okay, na? But one table of serial number, no unique. One table of serial number, unique. Now, if I want to go there, if I insert 1, allowed here, allowed 1 here, hey, 2 allowed here, here, next here 2, here 5, next 3, next 3, next 4, next 4, 5, 5, 5. Okay, na? Right. So now you can see, for example, if are you writing select a star from so and so table, what is the table? T1, where serial number is equals to 2. What's happened? Come on. Serial number comparing with each and every one, na? Then what? 3, 2, 5, 6, 7, 8, 9, 10, 12. That means to get this answer, how much time? 12 seconds. Now the same on T2. Select a star from T2 where serial number is equals to 2. Here direct will fetching 2, na? Otherwise if you search, for example, you search, how many searching? 1, 2, 3, 4, 5. That means searching time how much here? 5 seconds. Why, sir? Because simple reason. What is the reason? When in my table column, if more duplicates are there, then automatically searching time also increase. When you have a less duplicates, searching time also reduce. This is the advantage of unique. Okay, na? Right down below. What do you want to say? Unique indexes are reduced, are reducing searching time because there is no duplicate values. Now you can see, this is, don't write this one, just up to this. What is the syntax here? Let you see. Create, which index? Unique, index and index name on table name of column name. Okay, now? Now you can see, let you come back. Suppose I have a one table now, department table is there. On department table, first I want to check is there any indexes are there or not there. You can check DEPT and having any index? No. Now I'm creating one index. Create which index? Unique. So unique index UI on which table? Department of DNAME. Now tell me, can I create index here? Yes, because my department name column is not having any duplicates. Understand now? Now I try to create this. Now I'm trying to create this. Then it is accepted. Nothing problem. Okay, because no duplicate values. Then after created indexes on particular column, the column should not contains any duplicate. Okay, it was okay. And now you can insert now. Insert into what is the table? Department sending values, for example 50 comma sales and Hyderabad. I'm sending now. Allowed or not allowed? Not allowed. Why, sir? Sales already existing in my indexed column. And this is which type of index I created? Unique index. Then you just say it's showing error. What is your unique index name? UI. Duplicates are not allowed. But the same thing, can I go ahead here? Okay, suppose DBA. Can I? Yes. And go to your table. Allowed. But sales are not allowed, right? Next one. Functional based index. So functional based index is a one new index was introducing in our database here. And what is the use of this? And this index you never see in other databases. Okay, na? This is especially having in our Oracle only. Okay. So why, sir, in Oracle only it was introducing means the reason is what now? You all of you know in early classes I said to you, in Oracle whatever the data we saved, data is a case sensitive. Can you remember? Starting I was said, your SQL language is not a case sensitive. The queries can be write lower, upper, combination of upper and lower you can write. But storage data is a case sensitive. So that is actually the problem. Okay, no? So that is the reason to overcome that problem. We are using what now? Functional based indexes are introducing. So because of reason in Oracle data storages are case sensitive. But that is same as if you go to SQL server, it's not a case sensitive. You can save your data any manner. You can read your data any manner. It will come in MySQL, other databases. But Oracle will not come like this. Okay, let's see. Don't try it, first observe. Okay, for example, coming back to this is our table. One of my name I'm going to change. Update EMP set. Ename is equals to Smith, where EMP number is equals to 7902. Okay, fine. And now you just come out and see this is your table. But carefully observe in my ename column, there are two people are there with the name of Smith. But one name with the capitals, one name with the small case characters. Let you go. If I want to, suppose I want to retrieve the data whose name is Smith. Okay, I want to, what is my request? Write a query. Where ename is equals to Smith. Okay. Who came? Capital Smith came. But one more name is also there, na? This person not came. That means my output right or wrong? Wrong. Because I'm not asking the capital, upper, lower, I'm not asking. Whose name is Smith? If that name is available in my table, how many number of times, that all should be come. That is actually, yes or no, but it not come. And now we can see, if I'm giving here, small come, upper not come. This is the problem in Oracle. But in other SQLs or MySQL, this is not a problem. You will be sent like this, two people will come. You will be sent like this, two people will come in other databases. But in Oracle, not possible. Because in our Oracle, storage data is a case sensitive. This problem I need to overcome this. To overcome this, the people introducing what now? Functional based index, right? When we created an index object based on function name, based on function name. What is the syntax here, sir? Create index and give index name on table name of, then you have to give function name of, then give column name. So this is called a functional based index. Now see. Now by default, what it was identified here, by default in Oracle, data storage data is a case sensitive. Okay na? So if you are retrieving your data based on uppercase characters, then it will returns to you uppercase only. If lowercase only returns. But I want it not like this. Then what we want to do, I have to create. So create index fi functional index, otherwise FBI, okay na? Functional based index on which table? EMP. Suppose I'm using one function. Which function? Upper of e name. Which function using? Upper function name. And I'm trying this. Okay. Okay. Now you can see. So my function successfully created. After created, let's see how I want to call. Suppose if I'm calling now, e name is equals to Smith. What happened? You can see. Smith only come. Small only come. Because why, sir? Not capital. You are created index with which function? Upper, but you are not using na. Then index is working or not working? Not working, because what I said, if you want to activate your index, compulsory indexed column should be there. But now this is not index column. My index column how to prepare? Upper of e name. Concept understand na? Upper of e name, not e name, not e name. Upper of e name. That's why it is not come, because index is not activated. If you want to activate index, what? Upper of e name is equals to Smith. Then see now. Sorry, upper na. Then see now. Now condition matching. Now we can see. Yes. So what happened now? Smith small came. Smith upper also came. Why, sir? Any reason? Can you tell me how it is came? Simple. What it was happening here? First your table is there, yaar. This is your table. Before index, right? Before index, capital, small. Is it clear? Now I am creating what? Index created. On which basis function? Upper. Then what happened? This is a table. On this table we are creating what? Index. Index is what? Converting. Upper as usual convert. Lower, upper also convert. Then after creating index, that index facility I am using. Then see condition what? Smith, capital Smith. Then that's why these two are comes to you. Understand na? First capital small without index. After created index, what happening? Capital convert capital, small also convert capital. After that you are asking this condition. Now this condition you can see what I am asking, upper. So upper Smith, both are retrieval. Understand na? This is internally happening actually. Okay, right down below. Right. For example, for first example, you have to write what you want to do first. Update. Do update. EMP set. E name is equals to small case Smith. You can prepare here, where EMP number is equals to 7902. After that, you just call. Select star from EMP where E name is equals to Smith. Okay. Here what happened? Here we will get. Here we will get uppercase characters of Smith employee employee details from EMP table. Okay, this is one case. In second case, if I'm trying select a star from EMP where E name is equals to Smith. In this case, what happened? In this case, we are getting lowercase. Yes or no? We are getting what now? Lowercase characters of Smith employee details. Employee details from the table. Okay. This is what actually happening. Here observe. In the above examples, otherwise simply I can write if we want to retrieve employees details, from EMP table whose employee name is Smith. Smith, either uppercase or what now? Lowercase characters. Is either uppercase or lowercase characters. Okay, characters. Then we should create a functional based index on ename column like below. What is our example? How you are created your index now? Yes, now we got your index. Okay, create index, then after you can call. Now how to call? Select star from EMP where which function? Compulsory function, then only your index is activated, otherwise index is not activated. Smith. Now below right. Now we are getting the both upper and lower case characters of Smith employee. Employee details from a table. This is complete solution of functional based index. Okay, no? So this is one new indexes are there in a Oracle. Whenever you have a lower and upper and lower, okay, na, that kind of situations, if you want to get the details here, then directly not possible. Okay, na? Because of reason in our Oracle data is a case sensitive. That is the reason behind of this. Okay, and that's why the people introducing this functional based index. Okay, na? Last people. Clear? Oh, right. So these are total B tree indexes types. How many types here? 4. Simple, composite, unique, and function. And what is next? Bitmap. Okay. Bitmap index we will see on Monday. Okay. I have some personal work. Okay. We will see on Monday. Okay. Yesterday notes uploaded now. Huh? 30. Okay. Okay. Right. Notes uploaded, guys. Check it out once. Thank you.